Today we will discuss about reaction mechanism. First of all, we will discuss about substitutions reaction. Substitutions reaction is classified into two categories. One is SN1 and other is SN2. Substitution nucleophilic first order, substitution nucleophilic second order or bimolecular. First of all, we will discuss about SN2 mechanism. Substitution nucleophilic second order reactions or bimolecular. In this reaction, generally primary alkyl halide takes part. Primary alkyl halides, example is CH3Cl, methyl chloride is called primary alkyl halides. When methyl chloride is treated with aqueous KOH, substitutions will occur. Your substituted product will be methyl alcohol plus KCl, potassium chloride. In this reaction, chlorine atom is substituted by OH of KOH. In these reactions, KOH will dissociate to give you K plus OH minus. This OH minus is called nucleophile. That is why the reaction is called substitutions nucleophilic second order. Nucleophilic means substitution is done by using nucleophile. This is the reactions. Next, let us consider the mechanism of that reactions. The tetrahedral structure of methyl chloride is like this. This bond indicates above the plane, this bond below the plane, and a single line indicates on the plane structure. That means in methyl chloride, chlorine atom and this hydrogen atom are on the same plane with the carbon, but this hydrogen is at above the plane and this hydrogen is at below the plane. Now, when KOH is given to methyl chloride, OH minus is obtained as nucleophile. Now, this nucleophile will attack this carbon from back of the leaving group. Chlorine is called leaving group. As chlorine is substituted by the OH minus, that is why chlorine is called leaving group. So, when OH minus will attack this carbon, chlorine will leave and OH minus will make a new bond with the carbon. But in this structure, you can see that inversion of configuration takes place. That means all the hydrogen atom will go to the opposite from the direction in which OH is coming. This structure is called inverted structure and process is called inversion of configuration. The rate of the chemical reaction is directly proportional to the concentrations of the substrate and concentrations of OH minus. Substrate is CH3Cl and OH minus is called nucleophile. As the rate is directly proportional to two concentrations, that means concentrations of substrate and concentrations of nucleophile, that is why the molecularity of the reaction is 2, as the rate of the reaction depends on two concentrations, molecularity of the reaction is 2. That is why this type of reaction is called SN2, substitutions nucleophilic, bimolecular or second order. Next we will discuss about SN1 mechanism. SN1 stands for substitution nucleophilic unimolecular or first order. In this reaction, generally tertiary alkyl halide takes part. Suppose we are taking tertiary butyl bromide, CH3CCBr is known as tertiary butyl bromide. When aqueous KOH is given to this, it will give you tertiary butyl alcohol along with formations of KBr. In these reactions, two steps are involved. In first step, formation of carbocation occurs. Formation of carbocation. Carbocation means, cation means positive ion. Carbocation, when carbon is giving positive ion, is known as carbocation. So in first step, leaving group bromine will go from the compound as bromide ion. Here carbocation is forming. Look at the picture. In this carbocation, below the plane, above the plane structure is not applicable, because with formations of carbocation, hybridization changes for carbon. In this compound, carbon is sp3 hybridized, but when carbocation is obtained, hybridization changes from sp3 to sp2, and you know that sp2 carbon is planar carbon. That is why all the CH3 group will belong to the same plane with the carbocation. That is why above the plane, below the plane geometry is not applicable for carbocation. After formations of carbocation, nucleophile will come and it will attack the carbocation from two regions. Number one, it can attack the carbocation from above the plane, or it can attack the carbocation from below the plane. I will come to that point. Step 2, attack by nucleophile. OH minus is coming. In that case, OH minus can't attack this carbon from on the plane, because this plane is surrounded by three bulky CH3 group. So OH minus has no options to attack this carbon from on the plane. In these positions, OH minus can attack this carbon from above the plane or from below the plane. Below the plane means it can attack the carbon from back of this green board. So you can get two structures for two attacks. This will be your ultimate product in SN1 reactions. Now, rate of this chemical reaction is directly proportional to concentrations of substrate only. Concentrations of substrate only. Why? When a chemical reaction takes place in several steps, the slowest steps of the reactions is considered as rate determining step. So, in these reactions, two steps are involved, step 1, step 2. Step 1, formations of carbocation, slow step. Attack by nucleophile, first step. So, in these reactions, we will consider formations of carbocation as our rate determining step. So, in rate determining step, only substrate is involved. There is no role of nucleophile here. So, rate of the reaction is only depend on the concentrations of substrate. That is why the order or the molecularity of the reaction, molecularity or order of the reaction is equals to 1. That is why this is called SN1 reaction.